Welcome back everyone, I'm Jason Baskin, and in this video I'm going to expand a bit on another video I created about stretchy legs. I've already talked about how to create stretchy legs using expressions, and if you don't know anything about creating stretchy legs, you should check out that video first. But in this video we're going to do it using utility nodes. Maya's utility nodes tend to be the preferred workflow for most technical directors. They tend to be more stable and responsive than expressions, and they also give you some flexibility to add additional behaviors to a stretchy setup. So I'm going to hide my full rig, and let's just look at the basic setup I've already created with expressions. And here in the expression editor you can see that I've created a conditional statement which activates the stretch of the hip and knee joint based on the distance of this distance dimension node, which is created through the measure tools in the create menu. So what I want to do is create this same behavior using utility nodes. So to do that, we're going to go to Window, and we're going to bring up the node editor. And the node editor is a place where you can kind of see how Maya's different connections are fitting together, and you can make adjustments to it. And these types of node editors are common in many video editing programs. People that are creating textures and materials use these types of connections as well. So we're going to do it to basically create this same behavior here in the node editor. So we're going to make use of a couple different types of utility nodes. One is just a node that will divide this distance value just like we have here in the expression. So there's a utility node called the multiply divide node, and if you right click on the node editor and choose create node, you're going to see a long list of different types of nodes appearing. Again, many of these nodes specifically relate to shading, but if you scroll down far enough, you're going to see some math nodes and some kind of common nodes that can be used for rigging purposes. So the multiply divide node is the one that we're going to use in this case. I'm going to click on it, and you're going to see that that node will appear right here in the node editor. Oh, I accidentally clicked twice, so I'll delete one of those. There's that utility node. And if we double click on it, we'll see in the attribute editor that this node can be used to multiply, divide, and do math power operations. So we're going to set this to a divide behavior, and we're going to divide the leg distance attribute by a value of 9.2. That's what we've done in our expression. The next step is we need to find that leg distance utility node. And remember, that's right here. That's going to be the shape node of the distance dimension node that gets created using the measure tool. So you'll want to click on this, and you can work with it in the node editor by selecting it and then middle mouse dragging onto the node editor, and there is that leg distance shape node. Now these little circles here allow you to create inputs and outputs, and you can see that the leg distance does have some values. Here's the distance attribute, which we can see in the attribute editor. This was hidden from the channel box, but it is visible here in the attribute editor. And if we left mouse click on the outgoing circle and choose the distance attribute, we get sort of the beginning of a connection. You can see this arrow sort of string as beginning. If we click again on the incoming circle for the multiply divide node, we can choose where we want to feed this value. So the multiply divide utility node can actually handle vectors, so x, y, z values or RGB values. It can handle 3 math numbers at a time. We only need to use one of them. So we're just going to put it into the input 1x value here. And if we now select the multiply divide node, you'll see that distance value, 9.203, from the leg distance dimension node is feeding right here into the input node for our multiply divide node. So I've set the operation to divide, and just like I did in my expression, I'm just going to divide this number by 9.2. If I wanted to be really exact, I could divide it by 9.203. But as I mentioned earlier, you sometimes will modify this value just slightly to adjust where the bend point is on the leg. So I'll hit enter. And so now the value that has come into the multiply divide node will be processed and normalized to a value that we can use to scale our character. So we're going to want to feed the result of this multiply divide node into our legs, but we want to only do it if a certain condition has been satisfied. And remember, that condition is whether the leg distance is greater than 9.2. We only want to apply that stretch if the stretch value is going to be greater than 1. Just to keep things organized, I'm going to rename my multiply divide node. So I'm just going to call this stretch divide. And I'm going to be feeding it into the hip joint and the knee joint for our rig. But again, before we do that, we want to set up something that is similar to this conditional statement. Well, there actually is a condition utility node here in the create node list. Again, if you've closed this down, you'd want to right click, choose create node, and you're going to find a list of these nodes. And if you scroll down, somewhere down here past all the materials, you're going to find something that says condition. It's right here. So we'll click on it, and there's the condition node. This we're going to name our stretch condition node. Stretch condition. If we double click on this and look at it in the attribute editor, we get some terminology that's a little bit confusing. But remember that conditional statements are basically making a mathematical comparison. And in this case, we're going to compare a first value to a second value. If they match or if they meet the qualifications of this operation, then we'll do something. Otherwise, we'll do something else. So we want to determine whether the stretch value, if we look at our expression from before, we want to determine whether the distance, the stretch distance, is greater than 9.2. So what we could do is we could take the distance value here from our distance dimension node, and we can feed it here into the first term of our stretch condition. Now we have that value, first term 9.2, and we can say if that distance is greater than or equal to the stretch distance, 9.2, then we want to stretch the leg. If that condition is satisfied, then we want to use the value that comes out of this stretch divide multiply divide node. Otherwise, we want to use a value of 1. So we're going to take the value from our stretch multiply divide node. We're going to feed it into the stretch condition. So we're going to take our output x, we're going to feed it into our color if true r. Remember that many of these utility nodes deal with vectors. This one has, rather than x, y, z values, it has RGB values. So the color r is just this one here. So let's think about this again. Our first term, this is the value of the leg distance. That's just the same as this thing here. The value of the leg distance is coming into the stretch condition if it's greater than or equal to 9.2, like we have in our expression. Then we're going to take that value divided by 9.2 and feed it into our joints. So we're going to use this value from our multiply divide node, which is currently normalized to a value of 1, and we're going to stretch the legs. Otherwise, we're going to leave the scale set to a value of 1. Basically, these three utility nodes have accomplished everything we're doing in here, except for we're not yet feeding these values into the hip and the knee scale. So before we do that, I've got to delete this old expression because you can't have an expression and utility nodes both feeding into the same input. So I'm going to delete that expression, and then I'm going to make these connections. For me, it's easier to make some of these connections in the node editor, and some I think are easier to make in the connection editor. I like the visual clarity of being able to organize these things and select them through the node editor. But to make these connections from the conditional node into the joints, I'm just going to go to Window, General Editors, Connection Editor. And I've got my stretch condition selected, so it's loading here on the left. And then I'm going to select the hip joint and load it on the right. And I'm going to feed the out color into the scale x value. So which out color am I using? Well, I'm going to use the r out color. Remember, this is a vector, but I'm only using the first value, the r value. So I'm going to select out color r, feed it into scale x. You can see that it's showing up here as the hip scale is a value of 1. And that's correct because I haven't activated the stretch yet. And then I'm going to select the knee joint, and I'm going to load it on the right and make the same connection from out color R to scale X. With that done, I can close the connection editor, close the node editor, and we'll see that the leg now stretches just as it was with the expression editor, but all this is happening through utility nodes. So again, these utility nodes can accomplish many of the same behaviors as expressions, but they tend to be more reliable and more efficient, and they offer us some additional capabilities later on when we build more complex rigs. So hopefully this will be useful when you're working with your own characters. If you find these tutorials helpful, I'd invite you to subscribe to my channel and also to check out my other rigging tutorials on lynda.com. Thanks for watching.